So how many of you have been in this situation where you have a customer or a team member or a key stakeholder asking you, hey, can you deploy or create a prototype for me by the end of the month or by the end of the week, right? Or within the next couple of days, right? So myself as a solution architect in AWS, I've been in this situation actually a number of times, right? So I hope in this presentation you'll be able to get a good idea of how to deploy your end-to-end IoT and smart city solution on AWS and do it fast to foster faster innovation cycle for you and your team. So what is a smart city? So there are many definitions out there of a smart city, but to me, a smart city brings together sensor technology, connectivity, and analytics and AI ML to extract insights for the benefits of your citizens. So in everything we do in that smart city space, we try to place the citizen at the heart of our solutions, be it to improve the efficiency of how you monitor your energy utilization, or be it to better monitor your public utilities consumption, such as water, for example, or to enable new technology that will allow you to achieve your sustainability goals, such as electric vehicles, smart energy grids, etc. It could be also to improve the health of your citizens. That being said, one thing we always like to re-emphasize, and you might have seen these slides actually already. So as Werner Vogel says, he's our CTO, everything fails all the time, right? So a smart city application is an application that will keep running despite, touch wood, natural disaster, infrastructure failure, power outage. So in other words, a smart city is also a resilient city, right? And a tenet of a good smart city application is always designed for failure, right? And you can do this on AWS infrastructure. So what are the foundation of a smart city solution on AWS? So the first thing you might have already is actually files or data, right? Or building management system residing on your on-premise servers. But you might also have some edge data, some data generated in real time by IoT sensors, by your equipments, or by your legacy video systems, or by robots, even from social media and mobile. So this is your source of truth. And what you want to achieve is what is on the right? It could be operational efficiency. It could be uptime improvement of your fleets. It could be cost optimization. It could be sustainability goals, etc. So the question is really how to go from the left to the right. So the first step here is unlocking the data from your edge devices, from your equipments. So again, customers are looking to AWS and asking, how can we do this easily? So it's about instrumenting your edge devices with the proper software. So in AWS, we have a few of them. AWS IoT SDKs that you can install. We have Amazon FreeRTOS. We have AWS IoT Greengrass. We have Device Defender. So all of those software is something that you can download from the internet. You can download it from GitHub. This is free to download, free to use, actually. What those applications have as well are those libraries, right, that you can use to connect easily to AWS cloud services. So this is the first step to extract those data out of your edge. So once you've done this, now you can start ingesting the data in the cloud. So you could do batch ingest. So ingesting the data in bulk, in big chunks of data every few hours. Or it could be real-time ingestion, right? So ingest the data to the cloud as soon as they are generated at the edge. So in AWS, we have many services to do that. For the batch ingestion, you can use, for example, the AWS transfer family if you want to do secure FTP, for example. We have other service to extend the storage you have on-premise with the storage pool you have available in the cloud. For real-time ingestion, we have Amazon Kinesis services. Here in this session, I want to focus more on the AWS IoT core that you can use to ingest MQTT payload. That's the protocol usually used for IoT devices. The next step is, so ingesting the data is already a very good first step, right? But that's not the end of the story, right? This data you ingest in the cloud, you have to store them somewhere, right? So the typical, or I would say the recommended approach here, is to store all those data in a data lake, right? This data lake will serve as a single repository of truth for all your consumer applications. And having a single data lake have two main benefits, right? First benefit is you are able to govern and manage your data sets from a single view, from a single pane of glass. So manage the permission. Who can access what data sets? Second advantage is breaking those data silos, right? To extract insights for your smart city solution, you might want actually to correlate different data sets together. Example, it could be like data related to pollution, right? That you want to correlate with your traffic density information. And those data sets you might want to correlate maybe with information related to the health of your citizens. From those data sets, you might be able to extract additional insight and wisdoms. So again, in AWS, we have many services. We have Amazon S3, very cost-effective, scalable object storage. We have Amazon DynamoDB, a key value store, very scalable as well, low latency. In this session, I want to focus more on this AWS IoT Sidewise. So this is a fully managed services that you can use to collect, model, and analyze your IoT data. Behind the hood, you have a time series database used in this AWS IoT Sidewise. So in the demo later, we're going to use this. So once the data is in your data lake, right, you can start post-processing the data. You can massage the data. So you can do, again, batch processing. So doing that processing every few hours, for example. Or you can do real-time processing. Transform your data as soon as they reach your data lake. So again, we have many services to do that. I'm not going to go through the details of what services is doing what in details in this session. But you can see that all of this you can do very easily in the cloud. That being said, we have customers that are saying to us, actually, you know what, man, I can't put my workloads in the clouds, right? I won't put my workload in the cloud. And I want to invite my colleague Elaine for her to share some insight on this topic.
Right. Hi, everyone. Good afternoon. My name is Elaine. I'm pleased to see all of you here. From the describing of the situation Min has just talked about, you need data from many sources, and you need to process it in the cloud. So what shall we do? Let's take a look. Take a look at this. What if you are at somewhere where you need to process large amount of video data on the spot without huge data transfer? It could be ultra low latency video, audio encoding and streaming. What if you have a situation and environment where you have limited or no connectivity? Think about public safety and emergency response organization, how they will operate and how they can respond to incident faster and more efficiently. Wow, take a look. What about this? What if you have no bandwidth, but you still need to do a lot of data collection, processing, and also perhaps machine learning inferencing. So what do? We do recognize that you have a lot of workloads and applications that need to run on premises and at the edge where your operations are. And yet, you want to have the cloud capability at where you need it to be. So you can't have a set of inconsistent tools and experiences that will hinder your innovation journey. So what do? We know you want the benefits of the cloud, but you face those challenges. Well, AWS has a set of hybrid edge solutions to help you run workloads wherever you need it. Let's take a look. This is a continuum of choices from AWS that will allow you to run your workloads anywhere, wherever you need. You can run the workload in the region. You can run it in the local zones, in a metro city where you need low latency experiences, on-premises, and remote and limited connectivity locations, or even here where we have services for IoT. So, regardless of choices that you are making, we are extending the cloud capability to the edge, and all on a common, reliable, high-performance, secure environment and infrastructure. With that, you have the same set of tools, APIs, deployment, and security controls. And you can accelerate your innovation at anywhere you need. All you got to do is build your application once and deploy with minimal changes. So, when we're talking about an architecture, and you could use some of these choices to plug in like an edge gateway to ingest data, transform, and process it. How many of you have seen this box that I'm going to hold now in my hand? And guess how heavy this is? 2 kilos, size of a tissue box. And this is one of what we call the cloud in the box. Data transfer on the fly. So the choices are the Snow family and the Outpost rack, which is a cloud infrastructure that I can ship and deliver to the data center of your choices. So with all these choices, let's invite Lynn back to continue the presentation, followed by a very interesting demo. Thank you very much.
So coming back to our smart city context, right? So oftentimes in the real world, you would have many sensors that are not allowed to connect directly to the internet, for example. Or you would have video systems that are just connected only locally, right? So in this situation, you might consider having this IoT edge gateway to aggregate the data first, do some pre-processing, and sending only the data you need to the cloud. So in this situation, you might want to consider some of our AWS hybrid edge infrastructure. So continuing on our data journey, we've ingested the data from the edge. We've stored the data in a data lake. We've done some processing in the cloud. The next part is how to get those insights, those wisdoms from those data. So here we are using AI, ML, and analytics services. So again, we have many of those. Example, Amazon SageMaker, right? Which is a fully managed AI ML platform where you can build, train, and deploy your machine learning models at scale. On the analytics parts, we have dashboarding solution. We have Amazon Athena, which is a powerful query engine. But here, what I want to focus on is AWS IoT TwinMaker. So this is a fully managed services that will help you create your digital twins very easily. And we'll see that next in the demo. Now, finally, the last pieces. Once you've got this data in your database, you've got this data in your digital twins, you might want to represent those data or expose those insights to external worlds, right? So you could use Amazon API gateways to do that, right? Or you could use dashboarding solution to put together meaningful visualization for you, for your stakeholders. You can send notification with Amazon SNS. Right, so this is kind of the software stack that you can use on AWS to build resilient smart city solutions. So now let's get to the demo. So here the scenario I want you to imagine you have a new city block, right? As part of your city planning, you want to put roads, you want to put lampposts, and you want to assess what is the impact of putting those new roads, those new lampposts on the neighboring building. And you might want also to create your 3D model that represent those city blocks and place those sensors around your city blocks. So this is what we're going to do next. So remember, the first thing we want to do is instrument your edge devices, your sensors. So part of it is actually provisioning your devices to allow it to connect to the cloud. So we're going to use AWS IoT Core for that. And you can see here, what I'm going to do is provision a new IoT thing, right? So you can create it as a single thing, or you can create it as many things at the same time. Here I'm going to create a single thing for this demo. So let's give it a name. I'm going to call it IoT thing 1. You can specify your thing type. You can put your thing in different groups of devices. And you can define a device shadow, which is a virtual representation of the status of your physical sensors that we store in the cloud so that you can connect to regardless of the connectivity of your sensor. We're going to generate certificates. We're going to generate the credential you will need to put in your device. And we're going to attach a policies to your device. And a policy is just a JSON statement, a JSON file actually, that you use to define the permission you're going to give to your device. So here we're going to define a JSON document. You can do it also via the UI, but here we're going to use the JSON editor, and you can see here the permissions. We're going to allow the publishing, the subscription, connection, and receiving from IoT Core resources. So here I put a wildcard star, right? In production, you might want to restrict a little bit the IoT topics you will allow the device to access to. And this is very fine-grained. You can define different policies for different devices or different device groups. And finally, we're going to attach that policy to that device. So when you've done this is pretty much done. You have already created the credentials, you have provisioned the certificate, and all is needed to do now is download those credentials. So you can download it from this screen, right? So you can download the private certificates, you're going to download the private key file, you can download the public key file and the root CA. So those files are typically the files that you would need to embed inside your IoT device to allow it to securely connect to the cloud and do that mutual authentication. So once this is done, great. You are able to start sending those data to the cloud. So next, as I mentioned earlier, ingesting the data is great. Great first step. But the next step is actually deciding where to send this data after that. So you can see in the demo here, we are sending already some data to that core 2/env IoT topic. You can see the data starting streaming in, pressure, temperature, time of flight, etc., as part of the MQTT payload. What we're going to do now is define a rule to decide where to send those data next. And that destination I'm going to choose here will be AWS IoT Sitewise, which has a time series database behind the hood. So here I'm going to define a simple SQL statement. So selecting the data you want to send to that database. So select star from that IoT topic, meaning I'm basically selecting everything coming to that topic. And I will attach a rule and define the action of that rule. So you can see in the drop-down menu, you have many different targets, right? You can choose. Here I'm going to choose AWS IoT site-wise. And here I'm going to define where I want to send those data. So I'm going to specify the alias of the field I want to send the data to. Because this is a time series database, I'm going to define the timestamp. This is a Unix timestamp of type double. And here I'm going to use a substitution value. So the TOF field will be replaced by the actual value we see as part of the MQTT payload earlier. And so on. Here I'm going to define another target, which is for my temperature sensor reading. I'm going again to define the Unix timestamp. And again, I'm going to use a substitution value to replace these tTempLow parameters by the value that is actually received in the MQTT payload. And so on and so forth. So this is how you send simply your data to a time series database using AWS IoT site-wise. So the next part is, as the scenario I mentioned earlier, I want to visualize my city block in 3D, right? So I'm going to use AWS IoT TwinMaker to build the digital twins. So AWS IoT TwinMaker is something that you can also integrate to the AWS IoT site-wise database. So if I go to entities here, you can see the sensors and the parameters I've defined earlier, which is out of the box actually integrated to IoT TwinMaker. And I will show you later why we do this. Next, I'm going to go to my resource libraries, and I'm going to upload my 3D assets. Right? So in AWS IoT TwinMaker, we are embracing the reuse of your 3D asset. You're not going to create your 3D models from scratch in AWS IoT TwinMaker, but reuse what you have already. So here we're uploading a GLB file of a building, right? And finally, we're going to create a scene. So we're going to give it a name, Smart City, and create that scene now. So this is the scene composer, right? So this is the blank canvas you start with. And from that UI, you can add the various 3D models, the various 3D assets. So I'm going to add the one I just uploaded a few seconds ago. And here you have your first building in the scene. You can add additional building blocks, right? The goal here, again, is to recreate that simple city blocks. You can resize your assets, modify the heights, modify the width. And what you can do also is add some visual cues, actually. Some visual icons that you will link back to the sensors, actually, that you've ingested. And those visual cues will actually can change color or can change the icon based on the actual values you receive from the IoT device. And this is what we're going to do now. Right? You can see we're adding a so-called tag, right? And what we're going to do is link that tag, that visual tag, to an icon, right? And we're going to link it to the sensors we define in the database. So here I'm going to choose my sensors, and I'm going to choose to which parameters, to which value I want to link it. So that if the value, and I'm going to define a rule. So based on that rule, it will define the threshold. When you have a value going over that threshold, it can change the color of the tag. It can change the color of your texture. So that visually you will see on the digital twins if something is going wrong, for example. So that's how easy it is to create a 3D model with AWS IoT TwinMaker. So what's next? Once you have your data in the database, once you have your data in your digital twins, now you want to create a dashboard, right? To present this in a nice way, in a meaningful way for your operation teams, for example. So here we're going to add a new panel. You can see here you have a lot of visualization types. Out of the box, you have this AWS IoT TwinMaker Scene Viewer plugins. So here you can select your scene, the scene we created just earlier, so the smart city scenes. Click apply, and right away, that scene you created will load into your dashboard. You can add additional panels, right? So we're going to create here a simple graph, and this time, the source will be AWS IoT Sitewise, the database directly, right? So we're going to choose the property value history. We're going to choose the asset, that sensors, and what parameters from that sensors we want to display in this panel, which is temperature in this case, right? And right away, you have this graph being generated in real time. Going to choose the last 15 minutes, for example. So this is how easy it is to start creating your first visualization. Of course, this can be customized as you want. This is on Amazon Managed Grafana, so this is a fully managed services. You don't have to manage the infrastructure. It will scale according to the usage. So here I'm adding another graph, another time series, and this time I'm going to choose the lighting properties, luminosity, right, of your reading. And you can imagine those sensors would be placed all around the building or all around the city blocks to assess the situation. It could be particle, reading, pollution reading, those type of things. And that's it. You have your first dashboard, basically. So putting all of this together, we've instrumented our edge device with certain software, right, to send the data to the cloud. You might want to consider using some of the edge gateways. We've ingested this data with AWS IoT Core. We've configured some rules to send those data to a data store. So it could be S3. Here we've used AWS IoT Sitewise that has a time series database behind the hood. We've integrated and created our digital twin with AWS IoT TwinMaker and integrating that digital twin with our database. And then to consolidate everything, we've used Amazon Managed Grafana to ingest the data from the database and from your digital twins to present the data in a meaningful way. So wrapping up, you can build complete IoT solution on AWS. Build it fast. What I did here, when you start getting familiar with the technology, you can build it within a day or a couple of days, literally. It's a resilient, scalable, proven infrastructure. It's completely serverless. So you can get what I deploy here in the demo, you can actually deploy it by yourself using the resources on the workshop.aws website. And you can also use AWS and our partner network. We can identify the right smart city partner solution. We can help you validate and assess your architecture and your solution. And we can help promote your AWS solution together. On the skillbuilder.aws website, you have hundreds of resources, hundreds of courses that you can use. Thank you for attending this session. I hope it was useful to you and that can help you get started on your smart city solution journey. Thank you very much for your time. Please do not forget to fill the survey. Thank you very much.